Okay, let's see how we can use some of these things that we got from waves part 1. So this is waves part 2. We're talking about the equations, okay, that you need to be familiar with. Alright, we're going to be thinking about waves as a series of oscillations. Okay, we're going to be thinking about the fact that we know that if we sit on a harbour wall and watch the ocean waves, they travel. Okay, the wave crests are moving from A to B. Okay, so we're going to be talking about what we can calculate there. So let's just pick up from where we left off in part 1. We were talking about frequency of a wave, in our case f. Okay, we were talking about that as the number of waves per second. We can write that as an equation. Let's get that down. Okay, number of waves that pass a point, and anything per second is divided by time. Okay, we've got hertz for our frequency unit, we've got time, and the number of waves, that's just a number. Okay, but if we're talking about one wave, if our number of waves is just one wave, let's just focus on one wave passing a point in a certain amount of time. We know that for one wave, the time taken is called the period, or time period. Okay, and we can rewrite that as frequency equals 1 over t. So there's our first equation we need to be familiar with. Okay, we're going to collect some equations down the side here. Okay, so that's important. We've got frequency as a number of waves per second. If the number of waves is 1, instead of time, we're going to use time period, which is just the time it takes for one wave to pass a point, and we get f equals 1 divided by t, and we're using capital T because it's the time for one wave. I can play around with this and I can rearrange it in various different ways. Okay, if I'm starting with f equals 1 over t, just for fun I can multiply both sides of the equation by t, and I end up with that. That would cancel out and I get tf equals 1. Okay, if I've got tf equals 1, I can get t on its own if I divide both sides by f. Okay, so if I divide that by f and I divide that by f, I end up with that being cancelled out, and I have t time period equals 1 over frequency. Okay, it looks very similar to this one, doesn't it? But we've just swapped the f and the t down around effectively. So let's collect that in our box. Okay, that might be useful. Now what else can we do? We've got the wave down here. I'm imagining that my wave is moving from one position to another. Let's say I have I can measure distance. I can measure how far a crest moves, for example, so I can measure distance. Okay, it might be difficult. I might get wet if I'm in the sea, but let's imagine it could be any wave we could be talking about here. I can measure distance, and I can measure distance with a variety of different pieces of equipment, a ruler, a meter rule if it's a larger distance. If there's a larger distance still, I might use a trundle wheel. What else can we use to measure distance? Tape measure. You may be called upon to quote or describe an investigation, and you're going to have be aware of different pieces of equipment. You want to use the most appropriate piece of equipment Okay, so it's quite a large distance, you might want to use a trundle wheel rather than measuring lots of ruler lengths, if you know what I mean. Okay, so be aware of the equipment that you can use in an investigation. If I've got something moving from one position to another, I can measure the distance. I can also measure the time it takes to do so. Okay, I might use a stop clock or stopwatch, for example. Bear in mind that stopwatch, there's going to be some reaction time. There's room for error, human error. Okay, so I'm just brainstorming here. Okay, but the important thing is, in terms of waves, is if we can measure distance and we can measure time, there's something else we can calculate. We're talking about the motion of a wave. We remember that when we talk about the motion of an object, and we've got things like distance and time, we can calculate velocity. Okay, using an equation. Okay, velocity v equals distance and the letter for distance is s divided by time, and the letter for that is t. So in short form I can rewrite this as v equals s over t, and I expect you to be quite familiar with velocity equals distance divided by time, or displacement divided by time. Okay, but you know, when you identify your quantities in a question, if you've got distance and you've got time and you're talking about wave speed, okay, then we are just going to use velocity equals distance divided by time. If that's the quantities given, we can calculate the velocity of a wave. Okay, you can imagine sitting on a hardball watching those waves go by. You can watch a wave go past, you can estimate the distance or measure the distance, and you can time how long it takes to do so, and you can calculate the speed that way. Okay, so that's another equation. So now we've got 3. And interestingly, what we can do, if we're thinking about if the distance is one wavelength, we can say that the velocity, let's call it wave speed or wave velocity. Okay, we're still going to use the letter v because we use v for velocity or speed. Okay, if the distance is one wavelength, we know that the time taken for one wavelength to pass a point is period. Okay, we've now got v equals wavelength divided by period. Okay, I can expand this. I can separate these two things out as wavelength multiplied by 1 over t, and we know that 1 over t is the same thing as pull that down, frequency. So I can now rewrite this as v equals wavelength times frequency. And now we've got another equation. I can write it the other way around, it doesn't make any difference. It's normally that way around. V equals frequency times lambda. Okay, we've now got 4 equations. One you've used in previous topics on motion. Okay, these ones are particular to waves. This is the wave speed equation. But of course the importance of identifying your quantities in a question will dictate whether you need to use this one or this one. Word of warning with regards to using v equals distance over time. Make sure you're using the total distance travelled by the wave. So for example, if you are making a noise and that noise reflects off a wall, you're dealing with, for example, an echo, imagine you're making a loud noise here. We're going to measure the time taken for the wave to be received as an echo. Remember that the wave has to travel there and back. So if you know the distance between the source and the wall, the wave has travelled 2 times the distance between the source and the wall. Okay, so you just need to bear that in mind. If you're using distance over time, make sure you are remembering that you have to use the distance travelled by the thing that you're measuring. The distance actually travelled by the wave. So if we're an echo, it would be there and back. Alright, so be careful for that one. We've got 4 equations, depending on what you've got. If you've got distance and time, you're going to use this one. If you've got frequency and you've got period, if you've got frequency and you've got wavelength, you're going to use this one. Okay, we'll practice using that in another video. Alright.